Hi, Rick here for EDU Mobile. Now we're going to have a demo on some various forms of function. First function I have here, say hi, it just has no parameters and returns no value. Notice that when we define a function that has no parameters, we still need an empty parameter list. This is really a void tuple, but we're not going to talk about that right now. But we don't have to put a return arrow because we're returning no value. So this function just says print line hello Swift, and then we execute say hi. So the rest of these functions up to a point, I'm just going to show you the function, and then we'll have some calls to the function then below that. Here's a function that returns no value but does have a parameter. This is print an integer, and it prints out the value of such and such a function's parameter is a. Now this guy gives you the name of the function from inside the function. So this is very useful for debugging purposes. So this will say the value of printint's parameter is whatever we pass in. Here's a function that returns an int. Has one parameter, returns an integer. Here it's called neg, and we're returning negative a. This function add adds two ints and returns an int. So add two parameters and return an integer. Add a and b and then return it. Here's a function that uses its parameter as a counter. And we know that we're passing parameters in by default using basically let. Parameters are constants by default. So if we want to use a parameter as a counter, as we do in this case, or alter it in some way, we need to make it a var parameter. So we have a do loop, and then we're printing count minus minus while the count is greater than 0. Swap swaps two integers in place. Now these need to be in-out integers, or in-out parameters, and they are. So swap in-out a as an int, in-out b as an int. We let temp equal a equal b, and b equal temp. This is the classic swap function. But we do it in Swift using in-out parameters. Now, before swap, a might be 1, b might be 2. After swap, a is 2, b is 1. Now we get into something really interesting. This function returns a function. This construct, parent int, is the type of the function that we're going to return. So we declare an absolute value function. Now, of course, it would be trivial to make an absolute value function that returned its parameter as just the positive value. That would be trivial. What we want to do here is return a function that gives us the absolute value. So we declare two functions. Function positive returns a, and function negative returns negative a. Notice that these functions are declared inside this abs function, this absolute value function. And then we check to see if a is greater than or equal to 0, we return positive. Otherwise, we return negative. So we're returning a function. And we'll see how to call that here in just a second. So now we're going to test the above functions. num1 and num2 are defined as vars. First of all, we print num1 is num1, num2 is num2. Very good. And then we print int num1. So this will say the value of a in print int is equal to whatever it is. Now we're going to print int neg num1, print int add num1 with 4, count down num1, and then print num1 is num1, num2 is num2 before we do a swap, and then after swap, num1 is num1, num2 is num2. Here's the absolute value function. The absolute value of num1 is whatever abs num1 comes back as. Now notice how we call this guy. Absolute num1 is the function that we're calling, but we return a function that takes no parameters, and that part is here. And again, the absolute value of negative num2 is abs negative num2, and then whatever function it gives us back. Alright, so we're going to go that far. So I'm going to put in, at this point, print line stop here, so that we know to stop reading the output at that point. All right, so let's look and see what we've got so far. So here we go. We printed out hello Swift. Num1 is 3, num2 is 5. The value of printInt's parameter is 3. This was the... Let's find out. Okay, here we go. We did printInt. We got the value of printInt's parameter is 3. We did printInt on neg num1. The value of printInt's parameter is -3. And we did printInt on add num1 with 4. The value of printInt's parameter is 7. We then called the countdown function, and we got 3, 2, 1. We called it on num1. Then we printed out before and after a swap. So num1 is 3, num2 is 5. After swap, num1 is 5, num2 is 3. So that one works. Then we printed out the absolute value of num1 and negative num2. The absolute value of 5 is 5. The absolute value of -3 is 3. Now we note that we are not just calling an absolute value function, we are calling the function that was returned by that absolute value function. So that's pretty cool. And then we have stop here. All right, so now let's keep going and see what else we can do with functions. Bring this down a little bit. All right, now we're going to show the use of a function type to copy a function. F's type is a function that takes two ints as parameters and returns an int. So we've set up a var f with int returning an int as its type. We already have one of those type functions, so let's use it. We can assign f to the add function, and then we can use f in place of add. And that gives us 3 plus 5 equals 8. So f is functioning in place of the add function. Now we can look at default parameters. Default parameter names are external. So here's our raise function. Function raise a to the power whatever. So notice that to the power is an integer, but it's given a default value of 2. And we return an int. So here's I as an int, power as an int, equal 1. And then we go through for I equals 0, I is less than to the power I plus plus, power equals a plus power, and then we return the power. So we have result equal raise 5, which will square 5, printed out, and that gives us 25. But if we use the parameter result equal raise 5 to the power 3, we must use this parameter because it is an external parameter name. And we print line the result, and we get 125. Here's an example of a variadic parameter. This is our maximum. Find max of integers as a list of unsigned 16-bit integers, returning an unsigned 16-bit integer. Notice, though, that this we didn't talk about in the discussion. This is an example of Swift's for each loop, or a for in loop. The type of integer here is inferred because integers is a tuple containing unsigned 16-bit integers. So for each integer in integers, if integer greater than max, max equals integer, blah, 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 we know how to do that. And then we return max, and now we can go maximum equal find max of a bunch of unsigned 16-bit integers, and then print out the maximum, and we get 9, which our biggest integer happens to be 9. So we're right. Thank you very much.